Hello everybody, and welcome to the vBrownbag US edition for June 25th, 2014. I'm your host, John Harris, and today I've actually got a co-host, and his name is Anthony Hook. And Anthony's actually stepping up. He's a brave soul. He's going to kind of help us start hosting. How you doing there, Anthony?
I'm doing great,
Awesome. And then we've also tonight got Tom Hollingsworth with us again. He's at Networking Nerd, and he's going to be doing the follow-up on the CCNA DC Session 2 here. So we're going to get some more CCNA data center dropped on us tonight. Thanks, Tom.
Oh, no problem. Thanks for having me on again.
Awesome. We just got a couple of housekeeping items we're going to cover here real quick. So as usual, you can follow the vBrownbag hashtag on Twitter. There'll be questions posted there. If you've got questions to post, you're more than welcome to post them up there or go ahead and put them in the question window for us. Right now, as you know, we're kind of covering the Cisco certification track. And for those of you who actually were on for the CCNA routing and switching, or maybe you even just, happen to catch it afterwards or you got questions, Scott McDermott is still running his contest where he's giving away a couple of, books. One is the Networking for vSphere Admins or the CCNA Cert Guide library. And that's going through the June 30th of this month. So if basically how you enter that contest is you basically, tweet questions to him with the vBrownbag hashtag, and that's his Twitter handle there, which is the Scott M32768. Another thing to keep in mind is, if you're just kind of listening to a recording, maybe you're in a different part of the world. vBrownbag is global nowadays, so we got different editions all over the globe. So definitely, if there's one in your area, go ahead and tune into one of those and get involved in the conversation. And with that being said, I'm going to go ahead and turn it over to you, Tom. So I'm going to pass you presenter.
Thank you.
Awesome. Okay, give me just a moment here.
All right.
Pass it on over.
All right. Well, thank you very much. I appreciate it. Welcome back to all of those that are rejoining me for the second part of the CCNA Data Center vBrownbag. Had a great time last week talking about networking, but as we all know, every one of these exams requires a couple of different parts. And so tonight we're going to talk a little bit about 640-916, which is the Cisco Data Center Technologies exam. This is essentially everything that isn't networking. There are some questions about Nexus and NXOS on the test, but it's more from a product knowledge perspective and not from a networking theory perspective. So we're going to cover Nexus tonight. We're going to cover Cisco UCS, which is their unified computing system, their server offering. We're going to cover a little bit about some various other topics that kind of don't really have a home necessarily in the lineup. And then I'm going to take any questions that you guys have either for this presentation or the last. And if we have enough time at the end of it, maybe we'll get into a few of the things we couldn't do last week. So, as always, if you have any questions, shout them out, and we'll get going. So, let's start with our first topic, which is data center design. And this diagram may look a little weird. At first, it may look a little busy, but you'll understand a lot of the way that Cisco does things as we go along. You'll need to know these designs for the test, and they're kind of simple. So I wouldn't worry about them too much. Understand that Cisco loves a modular design to their networking. So you take something like, say, this access layer or the SAN layer. You can attach that to the core at any point, and what that allows you to do is build a network that's resilient and extensible. And that's basically what Cisco is trying to accomplish. So let's talk about Cisco's traditional three-tier networking architecture model. If you've worked on a network in the last decade, you've seen this before. You know what this is because Cisco loves this model. So the core of your network, I believe there were a couple of questions about network cores last week. The core is all about high-speed packet switching. It's all about trying to get packets across from one side of a network to the other as fast as possible. You don't see a lot of intelligence in the core. In fact, most core designs that I've seen with Cisco Nexus gear don't have any layer 3 technology in them at all. They're all layer 2, so that the packets go in one port and out the other as soon as possible. That's good because you see a lot of slowdowns when you try to do too much in the core. We'll actually get to that in one more slide. So this is your core layer. This is typically where something like a Nexus 7000 lives, which has a lot of aggregation ports. Now, if you drop down to the distribution layer, this is where your end-of-row switches typically come into play. This is where the access layer is aggregated. And from an exam perspective, the way you need to think about this is the distribution layer is where all of your services live. Policy engines, network analysis, QoS handling happens here. So if a particular packet stream needs to have a priority, this is where that's going to happen. And so this is where your Nexus 5000s live. If you're a campus LAN guy, this is where your Cisco Catalyst 4500s often are. They're the wiring closet aggregation switches. Now, the layer closest to the world in 3-tier is the access layer. And a lot of people look at the access layer and go, oh, this is really easy. This is where everything plugs in. Yes, that's true. And in a data center, this is going to be your Nexus 2000s, your fabric extenders, your top-of-rack switches. What's important in the access layer is this is where the QoS ingress marking happens. So for those of you who are not familiar with QoS, quality of service, this is a methodology for marking packets for special handling afterwards. So if you've ever signed up for like a concert ticket and they give you a place in line, or if you've ever gone to buy an iPhone and they give you a ticket and say, okay, you're number 57 in line, so you can go do whatever you want to do. When you come back, you can get back in line here. It's similar to that because it allows you to do certain things with the packets, to say, voice packets get to go in front of FTP traffic, or this particular packet is very delay sensitive, or in a data center, this packet contains fiber channel and can never, ever, ever be dropped for any reason. So this is where you have to make sure that your marks are correct when the packets are launched into the network, and that's why it has to happen down here at the access layer, because that's the closest network layer to your devices. Now, this layer, go ahead.
Oh, yeah, you must hear me as soon as I unmute there, Tom. Must be quite evident. I had one come in, and basically somebody was asking is, if I have some packets that I've already got tagged as QoS and some others that aren't, what takes priority?
Typically in this environment, if you're doing packet handling in the distribution layer and your packets are pre-marked, so a good example of this is voice packets. Voice packets always come off of a phone marked as Class of Service 5 or DSCP 46, which is expedited forwarding. They'll get put into the proper queue. All switches have queues that allow packets to leave the switch at a certain rate or in front of other switches. If your packets come in non-marked, workstation traffic or an application that doesn't need special handling, those all get dumped into a default queue. So they get best effort forwarding, which is usually what most traffic gets. So if you think about a situation where a workstation sends a whole bunch of FTP traffic into a network, if it's marked as best effort, that means we're going to do the best we can to get all of that traffic out where it needs to go. But if we have to drop a packet, make you retransmit it, we're not worried about that. As opposed to voice or video, where we're going to give them preferential treatment because we can't drop those packets in order to avoid quality issues. But at the same time, those are very predictable streams. We know how much traffic a voice call is going to produce, and it's not a very large amount. So we can say, well, we're going to give you X amount of bandwidth for this call, but no more than that. And then any packets that are left over, we're going to service those. I'll tell you right now, there's not a lot of QoS on the exam that I can remember. There's actually a QoS-specific exam inside of Cisco. It's a topic that is a very deep rabbit hole. I'm going to caution you by saying you won't need to know how to work on it right now for the purposes of being in a data center, but you will want to learn at least a little bit about it as you go forward. There's actually a really excellent Cisco Press book by Tim Szigeti. He's like the father of Cisco QoS, and it's about 3.5 inches thick, and you will spend years of your life studying it. It will be your Bible for QoS. Speaking of Cisco Press, one thing that I did not mention on the webcast last week, but I'll tell you guys right now, if you would like to purchase any Cisco Press titles from their store, if you use the coupon NETNERD, N-E-T-N-E-R-D, that will get you 30% off of any Cisco Press title. It's a good deal for books, especially if you want to get some additional reading material to kind of learn some of the topics that I may not cover in depth here or that you have some interest in outside of the network.
And they are just flooding in now, man. So somebody made a comment, do you recommend that people utilize a core as layer 2? And there was actually some commentary that came after that from another individual saying that typically they see the core basically doing layer 3 and routed. And they were kind of surprised that to hear you say that, layer 2 would be there.
Well, in a traditional 3-tiers architecture, the core does layer 2 packet switching. The layer 3 intelligence is moved into the distribution. That actually is one slide ahead of where I am because Cisco has a new model called the collapsed core. And in the collapsed core, they move the distribution and the core layers together because they said, well, we're kind of duplicating functionality here. It doesn't necessarily need to be broken out in a data center. Now, for those of you who remember that I mentioned something last week about a spine and leaf architecture, this looks suspiciously like spine and leaf, and there's a reason for that. It's because it's designed to get packets east and west across the data center as fast as possible. So if a server connected to this switch needs to talk to a server connected to this switch, it's 1, 2, 3 hops away. By the way, in a Cisco diagram, when you see a little line with a circle over it, this is denoting that this is a channeled link between these two switches. They're letting you know that information is passing back and forth here.
Okay, thanks.
No problem. In this architecture, you tend to see more layer 3 in the core. And from a design perspective, I've actually had this argument with people. And when I say argument, like I was banging my shoe on the table kind of argument.
Oh, wow, that sounds feisty.
Yeah, I was screaming in Russian. It was really bad. It was like throwback to the Cold War. The reason why we typically avoid to have layer 3 in cores is because of routing reconvergence time. In the event that something causes a routing table to throw up or needs to recalculate a path, you have to run an algorithm to do that. So you typically want to minimize that as much as possible. Remember last week when we were talking about spanning tree recalculations, how we want to avoid those as much as possible. Same kind of thing. You want your core to be as stable as possible. And with Cisco technologies that we have today, that's a little bit easier when we throw in things like FabricPath, which I'll talk about in just a few minutes. Let the routing decisions happen a little closer to your devices, because if the routing table needs to recalculate on the distribution layer, you're only going to impact the switch that runs the recalculation, maybe its neighbor. If you take the core down for any reason, that's called a resume generating event. It's a joke from the old CCIE days. CCIEs tend to run a lot of packet debugs in the lab because it doesn't really impact the traffic flow. And CCIEs will walk into a network and debug IP packet detail on a core switch and then wonder why the entire service provider network just cratered because of the amount of traffic that's flowing across that switch. And so you want to minimize the impact that you have in the core as much as possible. Now with collapsed core, it's a little different because you tend to see layer 3 functionality more built in there. But my understanding in a data center is that with some of the technologies that VMware uses, like vMotion, but prior to NSX, you have a little bit less layer 3 that you need to worry about. And so that's why you tend to minimize the amount of layer 3 in the data center for what it's worth. And remember that these are very stylistic, idealized models. Remember how I talked about OSI being a model that doesn't really map to anything in real life? You will find that when you get into a real data center that it won't look anything like this. It'll resemble this, but they'll have quirks, or they'll have, well, we had to patch this switch into that core because the majority of traffic goes over that link, or something like that. So take it with a grain of salt. Know the model and know the architecture for the test, but realize that it's not going to look like that when you get into real life. So that's the architectures. That's it. Cisco makes it pretty easy. You're either a collapsed core or you're not. And if you're a three-tier, core, distribution, and access. If you're a collapsed core, you have a core and access. That's it. Plain and simple. Now, what makes up these architecture models? What are the switches that are in there? Well, that would be Cisco's Nexus line of switches, and here they are in their glory. By the way, this switch right here, the Nexus, I believe that's a 7010. That's a half a rack. That's 24U switch. It has 3,000 watt power supplies in it. When you turn it on, it causes brownouts in small towns.
Yeah, I've seen those. I worked at a data center for a bit, and I remember the first time I saw one of those going, really? We've got to get that off of a pallet into that rack? They're quite beastly. Another question did come up. Somebody basically said, do they classify FEXs as access layer? Aren't they just remote line cards?
Yeah, actually, we'll cover that in a couple of slides. For those of you who are not familiar, Cisco's Nexus 2000 line, which is called a fabric extender, or a FEX for short, functions as a remote line card. You are technically correct, which is the most perfect kind of being correct. It's still considered an access layer because in the architecture, it is a device that a switch or that a host plugs into. There's no local switching that occurs on a FEX, though. It's basically a port aggregator. And yes, the most common analogy for a Cisco FEX is as a remote line card. So for those of you who may be familiar with a chassis switch, and we'll point this out in just a minute, so this whole housing right here contains power supplies and back planes and all the other stuff, but these little parts right here are the line cards. They contain the port aggregation. This is where you plug your stuff in. These don't really have a whole lot of smarts. The smarts actually are located in the modules here, which are the supervisor engines. In Cisco land, a Nexus 2000 is basically one of those line cards. And the device that it plugs into, a Nexus 5000 or a Nexus 7000, is actually the supervisor engine. It does all the heavy lifting. This is like a power strip, essentially. So in a model that you draw out, if you were like actually to sketch out in Visio or on the back of a cocktail napkin, the FEX does count as an access layer switch. It does have a minor amount of intelligence, but it can't actually make any decisions on its own. It has to forward to its switch upstream. So let's talk a little bit about the Nexus family, because you will need to know a little bit about these guys for the exam. So the Nexus 7000 is a Cisco data center core workhorse. This is the big daddy that costs more than your house when it's fully loaded. Probably costs more than 2 of our houses put together. It is a fully redundant data switch. You can put this thing in the core of a network, turn it on, and never shut it off again. All the updates can be done automatically without causing any kind of failover. It's a beautiful thing. That's what you get what you pay for. Now, it is the core of your network. It has all the full layer 3 capabilities. It has the most functionality of anything in the Nexus line. It also has service modules. One of the things that was introduced late in production compared to, say, a campus Catalyst 6500 core switch is that it contains service modules for things like network analysis and firewall services and other things like that. Where that comes into play later on down the line is that in a collapsed core, where this switch will be doing double duty as core and distribution, you can set it up so that certain virtual domain contexts are doing service analysis like network monitoring from a NAM module, and other things can just be doing high-speed packet access. When you turn one of these babies on, it sounds like a hurricane. It's a pretty beefy switch, but if you need it, you need it. There have been some questions in the past about the stability of the code train on Nexus. I know that Cisco's introduced a lot of they've introduced a lot of programs in place to kind of make sure that the code is up to snuff. They're always adding new features to this. I was actually doing some research for this podcast and came across a post from Ethan Banks about the introduction of MPLS into the Nexus 7K, which was like a watershed moment, because now it allows you to build out some new data center models. Always make sure you read the release notes for these switches. In fact, I would make it a good habit before you take the test to go out and read the release notes for, say, the latest NXOS release for the 7K and the 5K, to kind of understand what the differences are. So the 7K is the core. That's the big daddy that you buy one or two of these at the most. The 5K, on the other hand, the Nexus 5000 line, is the end-of-row switch. This is where all of your top-of-rack switches will aggregate back to. It's a pretty beefy switch on its own. As a matter of fact, a lot of people are starting to recognize the fact that in a small to mid-sized operation, the 5K can function as your core, especially in a collapsed core environment where you don't have a lot of traffic. So, I always get confused when Cisco talks about a small deployment being, I think something crazy like, 100 or 200 nodes. They don't consider it mid-size until you get to 500 nodes, and nodes are switches, by the way. The 5K has a completely different code train than the 7K. For those of you who are not familiar, the code train is the software that is loaded on the model of switch. So the 7K's software, while similar to the 5K, is not a mirror. And that's because they're constantly putting things in the 5K and then putting them on the 7K or vice versa. The 5K actually didn't have routing for a very long time. That layer 2/3 that I put up there, that actually didn't come along in the 5K for a very long time. But it did have MPLS before the 7K did. The important thing to remember about the 5K is that this is going to be doing a lot of heavy lifting for you if you decide to use the other Cisco Nexus switch that we talked about, which was the Nexus 2000, the Cisco Fabric Extender. And you will see the word Fabric Extender a lot in Cisco terminology because it actually pulls double duty. From a networking perspective, the Fabric Extender sits at the top of rack, and this is where you plug all of your server ports. So these are 10 gig. I believe they've come out with a 40 gig Fabric Extender recently, but I have to double check that. Please don't quote me on that. The key thing to remember about the 2K, it does not locally switch packets. Any decision that has to be made about switching the packet has to go all the way up to the 5K and come back down. And yes, that includes if you're going from port 1 to port 2 on the same FEX. It goes up and comes down. So the analogy that the person who asked the question earlier about is exactly right. It is a remote line card. So remember that. In fact, setting up FEX is a little bit special. You have to plug it into the 5K, and there's some discovery process that happens, and it's a little different. So know that before you go in and wonder why you don't have a CLI or anything on the Nexus 2K. Now, be aware that there are also other Nexus switches that are out now. There's a Nexus 3000, there's a Nexus 6000, and there's a Nexus 9000. To my knowledge, the test does not cover the 3K and the 6K, and I don't believe it covers the 9K either because the 9K is still too new, and it is more based on Cisco's application-centric infrastructure, or ACI, which is a little bit different. So for the test, know the 7K, the 5K, and the 2K. What are the differences? Where do they go in the data center architecture? Top of rack, end of row, core. By the way, end of row would map to your distribution layer, and top of rack would map to your access layer. If you know that, you will do a pretty good job on the exam. Any questions over the Nexus right away?
I am not seeing any come in right now, Tom. A lot of comments on it, but no questions.
Well, yeah, some people love the Nexus, some people don't. It is what it is. It's Cisco's data center switching line. So just be familiar with the differences in the line for the purposes of the test. But everybody knows that hardware is boring, so let's talk a little bit about software now. So the Nexus 1000V. For those of you who work in VMware or virtualized infrastructure, you've heard of this switch before. The 1000V is a completely virtual switch. It's designed to be Cisco's answer to VMware's distributed switch, VDS. The thing to remember about Nexus 1000V is that it's actually two separate parts. So you have to have one VSM, or virtual supervisor module. That's the intelligence for the whole unit. The parts that get deployed as the actual endpoint switches are VEMs, virtual Ethernet modules. these function very similarly to VDS that you're familiar with, or even a vSwitch. These provide port connectivity to virtual machines. Why on earth would you use a 1000V over a VDS? Well, a long time ago, all the way back in VMware 4, in the early days of VMware 5, ESX 5, you didn't have a lot of advanced networking features. It was basically the dumbest switch on the planet. But you needed some of those things. You needed access control lists or port security, or if you're familiar with Cisco's terminology for an ER span, which is a span port or a mirror port on a switch that needs to shuffle its traffic somewhere else. And QoS marking was a huge deal. VDS switches couldn't do QoS marking. Now, they've gone back and fixed a couple of these things. It's better. It's not perfect. I don't know how NSX is going to play in that. For those who are familiar with VMware's network virtualization play, NSX. For the purposes of the exam, know the differences between the old vSwitch, VDS, and the 1000V, and why do you want to use those. In real life, why would you want to use a 1000V? Because it's a Cisco CLI, because you understand Cisco, because you know how to work on it. Be familiar with the 1000V CLI and how it interacts with vCenter specifically. It requires vCenter. The VSM and the VEM are actually virtual machines that you spin up and attach. Once you've spun it up, though, you can telnet or SSH into it just like you would any other Cisco device. I'm kind of, I'm going through the 1000V and all the other Nexus switches pretty quickly. If you have any questions, shout them out, because I want to get into a little bit of NXOS here in just a minute.
Yeah, Tom. So actually one came in about some of the hardware actually right after you moved into the Nexus 1000. So somebody's looking for you to clarify whether the UCS FIs, the 64 or 6248s, etc., are still Nexus switches, or what the connection is.
I don't necessarily consider those Nexus switches. Those are actually intelligence pieces for Cisco UCS blade centers. So Cisco has a real problem with acronym reuse and this terminology reuse. So a fabric extender in the networking section is a top-of-rack switch. A fabric extender in a UCS server essentially functions as the I/O module. The other thing that the fabric extender, the 6100s and the 6200s, which we'll cover in just a little bit, have, that's where UCS Manager lives, the GUI application that allows you to drive UCS Manager. So while the names are the same, they're not the same. The 6100 and 6200 fabric extenders for UCS were actually out, I believe, before the FEXs were. So remember that while they say they have the same name, they have different functionalities. And if anybody wants to clarify that for me for absolute certain, feel free. But that's my understanding of it. All right. Let's talk a little bit about FabricPath here, because FabricPath is kind of it's a weird little orphan that doesn't really have a home. There was actually a question about it last week. So I had this big talk about Spanning Tree for like 20 minutes, and how Spanning Tree does a whole lot of wacky things in your network, and it destroys multipath and shuts down links and things like that. Well, the IETF got together. Actually, Radia Perlman, who was the inventor of Spanning Tree, saw an article in a tech magazine about a hospital network core that went down, I think, for 48 hours because of a Spanning Tree issue. And she said, that's just silly. Why would that happen? My protocol has grown to the point where it's almost unwieldy. So she went back to the drawing board and she created a protocol called Trill, Transparent Interconnection of Lots of Links. The idea is to be able to use layer 2 multipath to connect a mesh of networks together without blocking links, to select the best path or multiple paths, and to do it all elegantly. Well, everybody who looked at IETF Trill, Internet Engineering Task Force, it's one of the bodies that standardizes things, they looked at the IETF implementation of Trill and said, we can do that, but let's add a little secret sauce on top of it so we can give you a couple of extra features. And then let's give it a name that can be trademarked. Voila, FabricPath. So FabricPath is Cisco's implementation of Trill. and it is a layer 2 multipath technology that uses ISIS to basically do layer 2 routing. It does some other things. Now that it's using ISIS, it can actually cause packets to expire, which is great because that causes the bridging loops to go away. But for the purposes of knowing on a CCNA level exam, what FabricPath does is it eliminates the need for spanning tree. So when you install FabricPath on a Nexus switch, every switch has to be compatible with FabricPath to be able to run it. But once you do, it eliminates any need for spanning tree. It turns on the multipathing and all that other stuff. So where does this come into play from a perspective of you trying to attach a network that doesn't support FabricPath? Oh, well, that's easy. It's just a different hop. It just attaches like any other normal switch does.
Hey there, Tom. Another question that came in, and it was kind of after. We're getting them a little bit late here, but another one that came in is, isn't somebody had alluded to the fact that maybe that they thought that there maybe was a physical appliance version of VSM? I had never heard of that.
I think there used to be. I'm going to have to defer to people that used to use Nexus 1000V back in the day. I think there actually used to be a physical VSM. Let me find that out for you.
Yeah, actually, you know what? Tons of people started responding. I'm seeing a Nexus 1010 being listed here
right.
several
that
times.
Rings a bell.
Okay, so
yeah. The 1010 rings a bell now. That yes, there used to be a physical VSM appliance that you could connect VEMs to. I think it did so well that it got put out to pasture and shot quietly. So take that with a grain of salt. The majority of VSM deployments that I see done today are actually done virtually.
Yep, which would make sense. I mean, a lot of things are moving that direction. Somebody had also pointed out that maybe you had mixed up the FEX and the FI there.
Yeah, that's Rob Novak. Hi, Rob.
Yeah, he's calling you out, I guess. I don't know what's going on there.
Well, you know, Rob actually has a lot more experience using these things than I do because he used to do that for his former job at the world's largest Mickey Mouse organization.
Yes.
But yes, I did mix up. The Fabric interconnects are the 6100s and the 6200s that go on the back of UCS servers. So Cisco was smart enough to not confuse people with acronym and terminology reuse.
Oh, I gotcha.
Rob is allowed to correct me on anything that I screw up when I get to the UCS section.
Oh, man.
That's okay.
There you go.
All right, so that's FabricPath in a nutshell for the purposes of this CCNA. If you really want to get into the guts of how it works, I suggest you go watch Radia Perlman's Tech Talk over Trill and STP and Spanning Tree and download the IETF paper. And then show up to an IETF meeting and find a nice guy from Brocade named John Hudson and yell at him a lot because John is actually a friend of mine who is trying to get IETF Trill standardized. And he finally got through it. They're working on a couple of little issues. But Trill is going to be a huge deal in the data center, not just from the spanning tree perspective, but from the fact that FabricPath is slowly gaining a lot of traction from people that want to get rid of spanning tree wherever it happens to live. So let's talk about NXOS. This is one of the reasons why you guys showed up. Cisco has a separate operating system that runs on Nexus gear. It's the NXOS. Some people call it Nexus OS because that's kind of what it is. One thing you have to know about NXOS, it's an outgrowth of Cisco's old SAN OS that ran on their fiber channel switches. They picked a code revision, I think it was version 3, and said, well, this is now NXOS. It runs on both, and it has a similar code train. It is a little different from what you would consider to be Cisco iOS, the Internetwork Operating System. One of the biggest changes is that NXOS is a modular operating system. It's not monolithic. For those people who are not Linux developers, in the old days, the Linux kernel or any operating system kernel was monolithic, which meant that everything that you ever had to do with the kernel got built into it from runtime. Because if you ever needed a module, there was no other way to get it in there. Great from a speed perspective and from the ability to have everything you need. Really bad when one of those modules crashes and takes the entire switch down with it because, well, it's built in. NXOS doesn't do that. NXOS actually forces those modules to be built as add-on pieces. And you'll see this the first time you log on to NXOS and you try to create a layer 3 VLAN, and it'll give you an error. Why? That feature hasn't been installed yet. You actually have to go in and specify that feature and turn it on. One of the other features that's not turned on by default is Telnet, which is a good thing. Telnet is the most insecure way to get into a switch, and if I see anybody telnetting into a switch after, well, this recording, I'll slap you, because it's unencrypted. Use SSH. Use any other thing but Telnet. But the problem is Telnet's always listening on a Cisco switch unless you go in and disable it by default. In NXOS, it is disabled by default. It's not even turned on. You can't even trick the switch into responding to Telnet. Because it's a modular operating system, it actually loads a couple of different modules. It loads a bootloader, and that bootloader loads the kernel. So that's not like iOS. iOS loads the entire kernel all at once. That means if with a separate bootloader, you can do some fun things with it. You can upgrade the switch while it's running. In-service software upgrade, ISSU. You may not need to know that for the test, but ISSU is something you're going to use all the time. It gives you a lot of flexibility with the way the operating system is put together. But the CLI looks remarkably like Cisco iOS, and that's so the people who work on both kind of understand it. But note that there are some quirks. For instance, in NXOS, all of your interfaces are labeled Ethernet. If you're familiar with Cisco iOS, iOS labels the interface as the speed of the interface. So there's an Ethernet interface, which is 10 megabits. There's a fast Ethernet, a gigabit Ethernet, or a 10 gigabit Ethernet. NXOS doesn't do that. NXOS calls every interface Ethernet something, which is good because that way you're either addressing, you don't have to worry about, well, does this switch have a 40 gig line card in it or a 10 gig line card? You just have to remember which slot you're in and which interface you want to talk to. In NXOS, there's no do command. For those of you using later versions of iOS, if you try to show something from the global config mode, you get an error because iOS doesn't understand that you're trying to do something that's visible only from the enable mode or the non-config mode. NXOS is smart enough to recognize that the command you just tried to type in should be executed in global mode, not in config mode. So it will actually do the same thing that the do command does in later versions of iOS and go back to the right context, show you what you want to see, and then go back to the context you were previously in. It's a convoluted way of saying NXOS is smart enough to understand what you're trying to do. In the Nexus 7K, all of your a lot of the management is VDC based. So VDCs, virtual domain contexts, are a way to carve a big switch up into separate management domains. So last week we talked about using VLANs to carve a switch up into multiple broadcast domains. Well, in a data center, VDCs are like contexts for VLANs. And what that allows you to do is basically wall off pieces of the switch so that you can have multi-tenancy going on. So, eBay is on one VDC and CNN is on another. And you can actually restart separate VDCs on a switch without taking it down. That allows you to have a lot of fault tolerance. So know that VDCs are there. I'm sorry, Patrick Swackhammer just told me that VDC stands for Virtual Device Context, not Virtual Domain Context. Thank you, Patrick. The acronyms start kind of swirling together after a while. VDCs are a very important concept to grasp with Nexus gear. So make sure you understand that on a Nexus 7K, VDCs are the way that the switch is provisioned. As a matter of fact, if I'm not mistaken, on the 7K, when you log in, it has one VDC by default. You can start carving it up and assigning ports between VDCs, and you actually have to switch VDCs to do certain things because the ports just disappear. The other thing to understand is that NXOS has something called control plane policing installed by default. And control plane policing allows you to prevent things from just overwhelming the switch, like bridging loops. But the other thing it does is it splits the management of the switch off into a separate VRF, virtual route forwarding context. If you try to ping the management interface from the switch, it will fail. Why? Because you're not pinging the right VRF. And VRFs are a concept from MPLS, multi-protocol label switching. It would take a lot of explanation tonight, but rest assured that a VRF is just a way of segregating interfaces into separate ways to keep them from being overwhelmed by things.
Hey, Tom. The question came up. The Nexus 5000s don't support VDC?
Let me get back to you on that. I know that every bit of Cisco documentation, when you see VDC, it almost always talks about the 7K. 5Ks might support it, but let me confirm that, and if someone online wants to confirm that, you can feel more than welcome to. I don't know off the top of my head.
Looks like somebody just posted on Twitter.
Yeah. If they did, if it does, that's awesome. I am all for that. In fact, it'd actually be silly if they don't, because VDCs are very important. If you can restart a VDC, you can restart something that blew up without killing the whole switch. And think about it from a service provider or a multi-tenancy perspective. Do you want to restart eBay because CNN crashed? No. So if it doesn't support VDC, start writing letters. Tell them it's got to support that.
Awesome.
Cool. All right. So NXOS is not...
Somebody on the IRC just... Sorry about that. Somebody on IRC just let me know the 5548P does not support VDCs.
I believe that's the older Nexus 5K. So always make sure you know your model numbers and know which ones do what when you are looking at what their product support is. And especially with the 5Ks, the older 5Ks don't have the CPUs to handle some of the things that the newer ones do.
Well, I think what I'm seeing is it's not supported, but it looks like somebody stated that it still works on Twitter. So.
Oh, I love that. It's unsupported, which means it might work if you find out how to configure it, but if you call TAC and want help with it, good luck.
Okay, so folks, don't use it in production.
Exactly. Yes, unless it has a very big sticker beside it that says supported, don't use it in production, because if it breaks, they're not going to help you with it. In fact, the first thing they'll do is they'll make you take it off and troubleshoot what the problem is, and if the problem goes away when you take it off, they're going to throw their hands up and go, oh, it's unsupported. And that's bitten me in the butt more times than I care to mention. So NXOS is not iOS. So you can't just walk down to the local reseller or get a switch off of eBay, a 2500 router, and know how to work NXOS. The concepts are very similar, but they're just different enough to be maddening. So how do we fix that problem? Well, there's 3 ways to get practice on it. The first way is with real equipment. But unless you guys are willing to mortgage somebody's house, you can't afford to buy a 7K. So you're either going to have to rent time on one from a lab rack company, or you're going to have to find one that nobody's using and do a little practice on it. That's not going to fly. 7Ks and 5Ks are usually doing heavy lifting, and they're not going to let you monkey around with what's going on them, because anything you do on that switch is done live, and you could conceivably wipe out the Eastern Seaboard, which happened to Amazon a few years ago, not because somebody was playing with the switch, but you get the idea. Nobody's going to let you mess around with one of those unless they order them somewhere and you get like 20 minutes to play with it. So real equipment, while great, is probably not an option. So what are our other options? Simulators, right? Okay, that's great. Cisco Modeling Labs, or Cisco Viral, the virtual routing labs that they have been talking about for the last 3 or 4 months, are going to be Cisco's way of delivering virtual devices to you for learning. And I am a huge supporter of Viral and CML. I think it's probably going to change things. That being said, they're not supporting NXOS in the first shipping version. It's just a little too complicated. Viral is targeted at people who are trying to learn vanilla iOS. I'm hoping NXOS is going to get there. Don't expect it until close to the end of the year, realistically speaking. And I'm sure the first couple of versions are probably going to have a bug or 2 in them. Some of you may see the term titanium when you start searching for NXOS simulator. I know I did. I've known about titanium for a couple of years now, back when it was, shh, don't talk about that. Here's the thing with titanium. It's actually an internal Cisco-only emulator that was used and given to very, very, very large customers as a way to test Nexus configurations before they were put into production. It's a very, very early version of what CML and Viral were developed into. It doesn't work very well. First of all, it is so unsupported, it's not even funny. Like if you say titanium to somebody inside of Cisco, they'll probably blink at you and go, what? It's also very, very legally dubious. It's basically stolen software. And to top it all off, if you do manage to get a hold of a copy of titanium and you do manage to get a hold of the right iOS to put on it, you're probably not going to be able to figure out how to get the damn thing to boot in the first place because it's not great. It works about half the time. Don't bother. Seriously, just don't bother. There are better options out there. One of the ones I actually found was from a great guy named Todd Lamley. For those of you who are not familiar with Todd, Todd wrote pretty much every CCNA book for years. Todd and Wendell Odom are like the godfathers of the CCNA. Todd Lamley actually has an NXOS simulator that you can download that's like 20 or 30 megs. It installs to about 60 megs on Mac and Windows. And the link to the simulator is actually there. I have a copy of it, believe it or not. I was running it earlier, and I'll show it to you now. So it looks like the CLI for a Nexus 7D10. So if you type in show version, it will tell you that it's running NXOS. And here is your software version, your Kickstart version, all of those things. You can show it emulates a 7D10. It's a good software model. It actually will show you the majority of the things that you can see on a Cisco Nexus 7D10. Some of the things that are not supported there, so understand that this is not the most perfect way to learn how to work on a Nexus 7D10 or NXOS in general, but it's a good way for you to get a free access to it. The only thing it's going to cost you is you have to put your email address in as a registration method, and all he's really going to do is give you emails letting you know that he's updated the software. Honestly, it's Todd Lamley. I trust him. I bought enough of his books over the years. I think this is worth it. One of the things you can see inside of the switch is you can get used to the command line for those of you who have never used a Cisco switch before. So you understand that on a Nexus switch, for those of you who are familiar with Cisco iOS, you have to type configure, and then you have to use, I can't spell tonight, you have to use configure terminal. Well, on an NXOS switch, you can actually just type in conf, and it drops you right into config mode. You don't have to worry about that. You can play around with commands. So, for instance, we can do show, and we can type in V and hit tab, and it will tell me all of the available commands inside of NXOS that start with V. In this case, we can do VLAN. And if we use the question mark, it'll tell us if there are any others that we can do. And we can type in summary, and we can see there's one VLAN configured. And if we do show VLAN, it'll tell me all the switch ports that are loaded into that VLAN. One other thing you might actually find interesting is that you can, actually I need to go back into config mode, I do that all the time. For those of you who like to do routing, if you type in the command router, which is the global command to configure a routing on a switch, type in question mark, you don't see anything. Well, that's kind of silly. What do you mean you have a switch that doesn't do routing? Remember how I told you that Cisco iOS NXOS is a modular platform? Well, if you type in the feature command and then hit question mark, here's all the things that it can tell you are loaded, that are capable of being loaded on the switch. Notice the DGP, DHCP, interface VLAN, you're going to want to enable that one. OSPF, OSPF v3. These are all things that are enabled on the switch. So if you do show feature, it'll tell you all the things that are loaded and disabled, enabled, and enabled and not running. And if you notice down here, OSPF is disabled. Well, that means we can't turn on routing. So if we do feature, OSPF, and then we go back here and we type the router command and question mark, oh look, OSPF showed up. That's the power of NXOS. Features don't show up until you enable them. If you go back and you do a show feature, you'll see that OSPF is enabled and not running. The operating system is smart enough to remove things that are not enabled to clean the command line up. So if you type in a command and it's not there, or it's giving you an error and you know you spelled it right this time, make sure that the feature you're trying to use is actually turned on the switch. And you'll save yourself a lot of headache and possibly a TAC call. So that's NXOS, and that's so alien to the way that iOS works that a lot of people who are going from networking to data center the first time actually kind of get a little upset. They're like, well, that's just stupid. It shouldn't work like that. So, understand that. You can also go in here and you can do some show license commands. Everybody loves licensing commands. Always use the question mark. It may actually be disabled in your exam. They used to be real bad about disabling the question mark on CCNA level exams because they wanted you to memorize the commands. I think they actually have taken that away, because I'll tell you, in real life, nobody goes without using the question mark. The question mark tells you all the available commands that go to that spot. So the further down the line you go, so if you just do show and question mark, here's all the possible show commands. If I show VLAN, there's every possible command you can type under show VLAN, and it's summary. That's it. So get Todd's emulator, download it, and play with it. You're not going to break anything. You're not going to take down the Eastern Seaboard with this. This will give you enough familiarity with iOS or NXOS to be able to go into a switch and see things. CCNA level exams are less concerned with configuration tasks and more concerned with figuring out information on a switch. So if you know the show command, if you can say, show interface, show interface Ethernet 3/4. And that gives you the interface command. That'll tell you, what kind of interface is it, how's it configured, those kinds of things. You want to do that. So know how that works. Get this emulator and play with it before you go take the test. So you're not surprised if you get a simulator that pops up saying, oh, hey, go into the switch and find this information out. And you're sitting there in the test center pulling your hair out going, I've never gotten onto NXOS before. I don't know how I'm supposed to do it. Just trust me on that. So that's NXOS, the very, very high-level overview of kind of what's important and how it's different than iOS. I'm going to pause here for just a couple seconds, take a drink, and ask if anybody has any questions.
Yeah, somebody did have a question on that. They said, how many days can I run some features on them without a license?
120 days is the default. So all of your Cisco switches will always come with a grace period license. You can turn anything you want on for, I believe it's 120 days. On day 121, that feature disables itself, and you have to go get a license key. Not a bad thing, unless the feature that you were using actually was like doing heavy lifting traffic in production, and then you're going to get a lot of angry phone calls. So if you turn on a feature and find yourself using it after 15 or 30 days, go get the license for it. This is my rant on licensing. I hate it. It's a way to recapture R&D costs for certain divisions of companies. It's like a chargeback method. I hate it. I wish everything would come fully licensed out of the box. But in a perfect world, well, perfect world, you wouldn't need me to configure the switch. It'd be pretty easy. Talk to your partner. Talk to your Cisco rep. Get the features you need up front so that you're not scrambling. And having been on a phone call where I had to beg, borrow, and steal to get a license turned on for a customer a long time after it should have been enabled, that's not a fun phone call to have. So get it right the first time. Who else has questions?
Somebody stated the grace period has to be enabled to use it.
Yeah, you actually have to go in and turn on the feature, and about 50% of the time, and this is the same way it is on the campus LAN gear, I've never tried to enable a feature on an XOS. You have to bounce a switch to do it. It has to be loaded into memory the right way. Research that before you start turning things on. And usually what you're going to see is it's going to be an advanced feature like IPv6 or some really wacky routing stuff. It is what it is.
Alrighty, thanks.
Yeah, and Craig Johnson actually mentioned that you have the switch pointed to a syslog server, which you should. About 30 days from the expiring of the license, it will start throwing really ugly error messages at you. Please read those, and do not think that they are jokes, because they will turn it off on you. Get in touch with somebody. Get a hold of a Cisco partner. Get a hold of a Cisco rep. Come out there. Show them the error message. Email them the error message, and they'll know what part to get you. So that's enough about networking for now. I'm sure there'll be questions that come up in just a minute. Let's talk about UCS. So a very long time ago, Cisco didn't make servers, strangely enough. They made networking, and they partnered with other companies that put servers in. And then they said, hey, we can make servers. And so they did. It was called the California Project initially. By the way, if you look at the code names for a lot of the pieces that go into UCS, they're all named after places in California. Cisco made a server. They made the UCS, and they made it in two different flavors. They have a rack mount option, which is the UCS C-Series, and a chassis unit called the UCS B-Series. And one of the things about UCS that makes it important is it's manageable. I have dealt with OpenView and iDRAC and a whole bunch of other management platforms that, quite frankly, I could do without. UCS is pretty simple. It was designed from the ground up to be manageable. People that manage giant UCS clusters use UCS Manager to do it. They don't have to walk around and mess with things. The other thing is you've got these fabric interconnects. And I'm sorry, I said extenders. I should have said interconnects here. Thank you, Rob. The fabric interconnects are the I/O modules in the back of the servers. And for anybody who's ever looked at the back of a server rack that's filled with one-use servers and you see all the cables snaking off of it, monitor, mouse, keyboard, networking, all that other stuff, it's a mess. With Cisco UCS, it's very streamlined. There's very little cabling involved with it. And a lot of it goes into the interconnects, and all is right and well in the world. So the UCS C-Series is what you're used to seeing. It is a traditional rack mount 1 or 2U, or in some cases a little higher than that, server. Some people call them pizza boxes. These are manageable through UCS Manager. They're hooked into an interconnect. They come with hard drives and memory and CPUs, 2-socket CPUs, just like everybody is used to seeing. These are designed to get in the door for those people that say that blades are silly, or for the people that say that we don't need a blade unit right now. I actually sold more UCS C-Series when I was at a Cisco partner than I did anything else, especially because I was a voice guy, and it was, we certified it to run on voice applications ran on C-Series for a long time. One of the other things is that in Cisco's initial UCS rollout, the C-Series could hold like an insane amount of memory, something like, at the time, 384 gigs of RAM, which was mind-boggling. I think now they can go up to 768 gigs of RAM in a 2U box. So C-Series is what you're going to see the majority of when you go out, unless you go to a really big environment. Then you're going to see a lot of B-Series. So B-Series is a blade chassis. IBM Blade Center, HP, C-Class blade chassis. I think Solaris had a blade unit once. These are small footprint, high compute clusters that streamline the I/O and everything like that. So each one of these little boxes right here is a server with 2 hard drives to boot an OS off of, and some various units that you go in there. And you don't have a lot of storage on here because these guys typically plug into some kind of storage unit on the back end. But we'll get to that in just a minute. They're wonderful units if you have to stack a lot of compute power into one location at a time. I wish I actually had a shot, I forgot to put it in here, of the back of this thing. As Rob told me, in order to hook a UCS B-Series chassis into the real world, you need 2 power cables, 2 twin-ax cables, and 1 or 2 management cables. That's it. It's the least amount of cabling you're ever going to hook up into a server.
It's beautiful. When I was at the University of New Mexico, we had just gotten some of those, and it's amazing how much cleaner it is.
Yeah, it is. I've spent a lot of my life tangled up in cables, and I hate them. But Cisco's doing a great job of getting rid of those. So the B-Series is really great. Let's talk about UCS Manager for a minute, because this is really where it's important. This is what differentiates Cisco UCS from a lot of the other places. So UCS Manager is GUI-based management for UCS, period. The screenshot's a little small, but if you look down here, it'll show you all of your chassis servers. It'll show you all your fabric interconnects. It'll show you anything you can attach into this unit. You can provision it all from here. Click, drop, drag, it's done. It's real easy to configure. One of the pieces that makes it easy to configure is this thing called a finite state machine, or FSM. It's a workflow. It's the object model management workflow. It's great because it is smart enough to figure out when you screwed something up in the configuration and stop and say, are you really sure you meant to do that? Are you really sure you didn't mean to do this? And it gives you a really great way to kind of sanity check your configs before you put them into production. And that's great when you're trying to figure out, well, which one of these servers am I supposed to mess with? So, you've got, the service profile is great because that means you can provision a specific profile for an application or for a virtualized host, and that service profile can move between blade chassis or between servers. So in the event that one of them blows up, you can get it back online relatively easily. Everything you could ever want to do is here. I didn't spend a lot of time working on UCS B-Series because a lot of my customers didn't have them, but having applications like this, but not this powerful, was a really wonderful thing. So one thing I didn't get a chance to put in here, but is available if you search for it online, there's actually a UCS simulator, UCS Manager Simulator. It can be downloaded as an OVA and VMware template file, fired up in your favorite virtualization host of choice. And you can actually play around with UCS Manager just like the NXOS that we just showed. Get familiar with it. Understand it. I highly, highly recommend it, and they keep it pretty updated. So that's it for UCS. There's a lot there, a lot deeper than I went into it, but to be honest with you, for the level of the exam that we're talking about, you need to know what UCS is, and you need to know the difference between the C-Series and the B-Series. That's about it. There are no questions just yet. Let's talk a little bit about storage, because storage is the most boring thing on the planet, and I'm allowed to say that because my boss is a storage guy. Cisco has a storage switch called the MDS 9000. Why is the MDS 9000 important? Because it's a fiber channel switch. So for those of you who are not familiar with fiber channel, it's one of the biggest storage protocols out there. And note that that is spelled the British way with RE instead of ER. If you spell it with ER, people are going to look at you funny. Fiber channel is a high-speed storage network that allows you to access SANs, storage area networks, for things like blade chassis and so on and so forth, large storage volumes. And you have to hook those fiber channel SANs into your servers through a fiber channel switch, because fiber channel is a lossless network, but it can't go more than, I think, 2 hops before it loses its mind. So you have to have a fiber channel switch to plug everything into. And then you can do things with fiber channel like zoning, where you can take certain storage volumes and only show them to hosts that need them and hide them from other hosts. I didn't do enough fiber channel when I was doing this for real to really understand it like I should, and there's still a lot of it out there. That's one of those fun debates that people are talking about now. Oh, fiber channel's dead, and these people are faster, and this is better. Realistically speaking, fiber channel is not going away anytime soon, and Cisco has made a lot of development into making sure of that through the unified fabric. So now that we have the Nexus 7K in the core, we can work with MDS 9000s and things like that. Some geniuses over at Cisco said, well, why can't we converge the fiber channel into our Ethernet? And they did. And they took all of the quirkiness of fiber channel, the fact that it's a lossless network, and they made it work over 10 gig Ethernet. Because fiber channel doesn't use traditional networking interfaces. It uses 2 gig, 4 gig, 8 gig, 16 gig, and on into the future. Cisco uses fiber channel over Ethernet as a converged storage architecture. So what that means is reduced cabling for your servers. So instead of having, cable for your network interface and a cable for your fiber channel interface, you plug one cable into the server. The fiber channel packets are tunneled inside of Ethernet. They're encapsulated on the switch. The fiber channel packets go to the SAN where they're supposed to go, and the Ethernet packets go to the network where they're supposed to go. And it works. And one of the things you can do with fiber channel over Ethernet that Cisco's been working on for a while is you can actually make the network bigger. Remember how I told you that the SAN has to plug into the switch and the server has to plug into the switch, and that's the limit of the size of the switch and the size of the network you can have? Fiber channel over Ethernet's working on ways to make that a couple hops bigger, which doesn't sound all that great until you realize that making fiber channel 2 hops bigger changes the way that a lot of data centers are configured right now, because that means you can move the fiber channel around. For the test, know that unified fabric is fiber channel and Ethernet merged into one, and that you can encapsulate fiber channel and SCSI traffic into Ethernet frames and launch them over the network. So that's unified fabric. And that's really what I've got to cover for the purposes of 640-916. It's a terminology exam. It's a model number exam. So know the difference between the 5548 and the 5596. Know a little bit about fiber channel. Know the difference between a B-Series and a C-Series UCS. You're going to spend a lot of time on Cisco product pages. That's it. Questions over that? And a question for you guys. I have a couple of slides over some networking terminology, layer 3, things like routing protocols and IP address stuff. If you would like me to cover that, I have nothing going on for the next 20 minutes.
I'd be good with that. I mean, I can stay on and we can capture it.
Okay.
Might as well.
All right.
We'll take all the knowledge that you can drop, Tom.
You better be afraid of that. There's a lot of messy stuff floating around up here. All right. Well, if you guys have any questions about any of the stuff we talked about already, feel free to ask them. We'll just go in. Do have a question Patrick actually asked. How much does the test cost? Well, let's go over here to www.cisco.com/go/certification. And we go down here to the CCNA data center, and when it loads, if it loads, we'll find out. As I said the other day, well, when your internet doesn't work for 10 seconds, you start wondering what's going on. So 640-911, which is the data center or introduction to Cisco data center networking, is. Did they forget to put the? They did. They forgot to put the price on here. My apologies, Patrick. I'll have to get back to you on that. I would guess it's the standard CCNA cost, which I haven't paid for in a while. It's a couple $100 usually. Let's see if Pearson's going to tell me. Probably not. Cisco exams usually run between $100 and $200. Unless you're taking the big ones. Actually, I think Jeff Fry, Guy PA on Twitter, his blog is fryguy.net. He actually posted a blog post today. I think they raised the prices of all their exams for some reason.
Somebody mentioned if you take it at Cisco Live that it's free.
Yes. Well, if you go to Cisco Live every year, one of the perks of getting a conference pass is that you get one test for free if you sign up ahead of time. They'll let you take one exam for free. They'll actually let you take any number of exams that you want at 50% off as well. the most popular two exams that I know that are taken at Cisco Live are the CCNA and the CCIE written. The IE written, because it's $300. I think it's actually $350 as of like today, and because a lot of people are trying for the see if they're ready to take the lab. CCNA, for those people who are going to Cisco Live who know a little bit about networking and are ready to they're ready to jump in with both feet. They're like, well, I might as well use the free exam to do it. So jump right in there.
And I believe Robert actually just posted the link for the pricing info on Twitter.
Good. Yeah. Check that out. In fact, if you're interested in UCS at all, follow Robert. he needs the followers. The community is really good. If you have a question about anything on CCNA Data Center, ask on Twitter. There's a lot of people out there that are studying the same as you. There are a lot of people out there who are, just as curious about it as you are. All right, so let's talk a little bit more about networking because, hey, I'm the networking nerd. One of the questions you may get asked on 640-911, which is the data center networking exam, is about RFC 1918 address space. The short version. About 20 years ago, they figured out that at the current rate that they were expending IP addresses for hosts connected to the internet, they were going to run out in 2012. And now, remind you, this is 20 years ago. This was before the World Wide Web existed. This was back when things were supercomputers were connected to universities via Telnet and using FTP to transfer files. So they went out and they said that we're going to set aside 3 blocks of addresses that are going to be for private use inside of networks only. And this is back when address space was classful. So if you ever see an address space that starts with 10, 172.16, or 192.168, you need to pay very close attention because that is a non-routable address space. Think of it like a 555 telephone number in a movie. It's technically a number, but it doesn't mean anything. So hosts inside of networks can communicate with these just fine. So if you're 10.0.0.1 and the guy next to you is 10.0.0.2, you can talk to each other just fine. But in order for those hosts to have any significance on the public internet, they have to be translated. And that's usually at a gateway device that does network address translation. In fact, it is your responsibility as a network operator that you are supposed to block those prefixes from leaking onto the internet. There should be a filter set up on your outgoing interface that says anybody who has a 10 dot whatever address or 172.16 address needs to be stopped before they get out. That's because the next hop router is not going to know what to do with them. Understand that RFC 1918 is internal only addressing and has no significance on the global internet, and you'll be fine. So you're probably wondering on this last slide what those slash numbers mean on the end of the addresses, and that's a big rabbit hole about subnetting, about using the number of binary bits in an address to figure out how many hosts you can put on a network and what the valid address space for that network is. And to be honest with you, I could probably do an entire hour over nothing but subnetting. But thankfully, Scott McDermott did that 2 weeks ago on his CCNA brown bag. You will need to know how to subnet for this exam. If you are taking any CCNA exam, you will need to know how to subnet. A word of caution about subnetting: don't just practice how to subnet and then leave it at that. Extend that knowledge. So if you know how to find how many hosts are in a /26, that's great. Then immediately you need to know which host is the broadcast address and which host is the network node or wire address. Always be finding that. Always know, which of these are valid or how many hosts there are. Don't just concern yourself with the math. Think of it like a word problem, because on the exam it is going to be a word problem. And almost everyone who's taken the CCNA for the first time comes back to me and says the exact same thing. I ran out of time. I didn't know it was going to be that tough. at the time, I've taken so many certification exams in my career as a VAR that I could probably regurgitate questions from now to the end of time. The Cisco exam was the CCNA was the toughest exam that I took at the time I took it, because it was the one exam that needed you to go deeper into every question. It wasn't just, what is the name for this, or what is the command for that, or if you're a fan of Microsoft exams, you're an administrator for Contoso Limited, your dog's name is Fluffy, and you're married to a wonderful woman named Sue. What is the name of the command used to rebuild the DHCP database? They're always really wordy with their exams. With Cisco, it's very calculated. What is the name of the command to do this and receive this output? Well, you gotta think a little bit. You're like, I know that command, but that doesn't look like the output you're supposed to see. So for the purposes of subnetting, practice it until you know it cold and can do it without a second thought. But know that they're never going to ask you just a basic subnetting question. It's always going to be leading to something. Which of the following are broadcast address for these two networks? Something along those lines. So let's talk a little bit about routing protocols before we wrap up here. So routing protocols carry information between layer 3 devices, in this case routers, and they tell the routers how to get packets from one location to the other, because without a routing table entry, the router doesn't know where to send the packets. And a routing table is real easy. A routing table consists of a network prefix and an egress interface. So for all the packets bound for this network, go out that interface. That's it. But we have to build that table somehow. And that's what a routing protocol does. Now, please know that a routing protocol does not carry any user data at all. I hear that mistake made often. In fact, I made it once in front of Marko Milivojevic, who's a CCIE trainer. He slammed me for it. He's like, they don't carry data. They carry information about how to route data. Fair enough. There are two basic kinds of routing protocols. You're either distance vector or link state. And we'll cover those in just a second with some examples. RIP is the oldest routing protocol that I can think of. It's actually, if you go to a Unix box or a Linux box and you type in route D, that's RIP. It's the routing information protocol. That's it. RIP basically works like this. It has a routing table, and every 30 seconds it sends that routing table. It just says, here you go. And it's stupid, essentially. But it works. For very small networks, RIP works really well. And I've had to use it on several occasions. It's distance vector. What does that mean? Every other router in the network is a hop. So for me to get from one side of the network to the other requires me to go 3 hops. So 1, 2, 3 routers. RIP actually has a maximum metric. You can't go more than 15 routers. If you go to the 16th router, it's actually the packet gets dropped. I put routing by rumor on RIP because one of the things that RIP doesn't have any visibility outside of itself. What it does is it accepts what it gets from its other neighbors and says, well, that must be the routing table, right? So it builds that. And you get into really, really weird situations with RIP where sometimes the routing table is wrong, or a router in RIP is advertising a route that's no longer available, and so it puts the network into a loop. In real life, the only time you're really going to have to mess with this is when you're decommissioning RIP somewhere, or you had to turn up RIP to get a couple of nodes working right. And if you're trying to redistribute RIP into other protocols, if anybody out there online has ever studied for the CCIE and I say the word distribution, they just cringed, redistribution, because that's when things get hairy with routing protocols. Know what RIP is and know why it's a bad choice for modern networks. Here's another reason why RIP is a really bad choice, and it's actually kind of funny. As RIP routing tables get bigger and bigger and bigger, it takes longer to transfer them. There have actually been situations in the past, I was told this by an instructor one time, where the routing table was too large to transmit in 30 seconds to its neighbors. And so they started running into problems where the routing tables were wrong because they literally could not get the information to the other neighbors fast enough. So RIP is great for when it was written, but most people don't use it anymore.
Hey there, Tom. Question did come up on Twitter. Anthony was just asking, is IPv6 subnetting, covered on the CCNA exam?
It's actually a really good question. I think you have to know a very basic level of knowledge about IPv6, why it's different than IPv4. I don't think they're going to get really heavily into subnetting on IPv6. It's actually easier in v6. The boundaries break down a little bit differently. I think I can say this now because it's been years ago, but I helped write some exam content for the original CCNA exam years ago. I actually got into a fight with one of the content creators about the level of v6 knowledge on the CCNA. I thought it had to be more basic about informational level. And so I think that they finally saw my light. Look over the exam contents. Look over the blueprint. The blueprint is the key. If the blueprint says you need to know how to subnet IPv6, then know how to subnet it. I don't remember seeing it on the blueprint. So I think you're safe there. Know what an IPv6 address looks like. Know why it's a better choice than v4. That kind of thing.
I'm actually seeing some people are telling me that hex conversion is on the blueprint, and somebody else is telling me that some summarization and address scopes are on there as well.
Yes, I do believe hex conversion's on there. You have to convert numbers from hexadecimal to decimal. I hope you don't have to convert them to octal.
So learn the hex.
Learn hex. Yes, you have to know hex and IPv6 because all addresses are hexadecimal.
Absolutely.
Yeah. So understand the concepts of route summarization and why they're important. Again, there's a lot of overlap between the NA routing and switching and the NA data center. Route summarization in a nutshell is taking devices that are hiding behind a certain boundary and kind of saying, well, instead of saying I'm going to give you 4 different routes to get to those 4 different devices, I'm going to give you one more general route that points to me, and then I'll make the decision on how to get those routes to those 4 devices. And there's some math that has to happen there. So you have to understand, well, where's the bit boundary that contains all of those addresses but none of the other ones that I'm supposed to have? And that goes back to subnetting. Route summarization, subnetting, supernetting. Understand all of that cold. Go watch Scott's CCNA routing and switching update, and when he starts talking about subnetting, write it down and practice it. I'll tell you, I'm a CCIE. It took me a year to get subnetting. It finally took one person who explained it to me in a different way that I just clicked and went, holy crap, that makes sense. It's hard. I'm not going to lie to you. It's hard. But if you get it, the rest of the exam is gravy. So I'm going to go quickly through the rest of these routing protocols. So RIP is good for when it was. Nobody hardly ever uses it anymore. So let's talk about EIGRP for a second. EIGRP, Enhanced Interior Gateway Routing Protocol, is Cisco proprietary method to make a routing protocol that was better than RIP. And it's an advanced distance vector protocol. Some people will call it a hybrid routing protocol because it takes some of the things that RIP and the Cisco distance vector routing protocol, IGRP, didn't do very well, and it fixes it. So one of the things that EIGRP does better than RIP is that it actually keeps track of the people that it's talking to. It has neighbor relationships where they send hellos to each other so that when a neighbor goes down, that can trigger an update in the network. Because with RIP, if a router went offline at 1 second after it received an update, it had to wait 29 seconds before that router disappeared. So you're blackhauling traffic the whole time. With EIGRP, because of the neighbor relationship, it knew that neighbor went down the second it went offline. The other thing is that EIGRP understands the topology of the network. It knows the path costs everywhere. This means that it can get faster updates. And the other thing it can do is it can actually fill in the holes in the routing table as opposed to having to send the whole routing table with every update, which means less bandwidth, it means faster updates, it means a little more resiliency. EIGRP is not bad. I use it a lot when I have to just stand up really quick routing and I'm in a Cisco-only network. Turn it up, turn it on, and it just works. It figures everything out. It actually uses a proprietary implementation algorithm called Dual, the diffusing update algorithm, to calculate path costs. A real fun joke that a friend of mine used to tell me, Narbit Kacharians, who's a CCIE training provider, EIGRP, for those of you who eventually go on to the CCIE level, there's a metric calculation that it actually does. It takes into account 5 different metrics in the network: bandwidth, delay, MTU, reliability, and I forget the 5th one, and Narvik's going to shoot me for this. But it actually doesn't use all of them by default. It uses bandwidth and delay. And Narvik's hilarious speech starts out with, "So there are people in this world who drink and people who do drugs. Both of these people wrote EIGRP." And he goes into all of the different ways that you have to calculate the bandwidth and the link plus the sum of all delays in the network, and then he gets to the end and he goes, "So the people who do drugs decided we're going to multiply all numbers by 256 to be compatible with EIGRP." And so, you know, that's one of the things. So IGRP and EIGRP are compatible with each other, but nobody uses IGRP. Remember how I told you nobody uses RIP? Well, a few people use RIP. Nobody uses IGRP anymore. Most people that do it use EIGRP.
Hey, Tom. So
Yes.
a question did come up. EIRG or eGRIP, is that only Cisco only?
Yes. Sorry, that's a sticking point. It is EIGRP, not eGRIP. That's one acronym you never pronounce.
Oh, my bad.
EIGRP is a Cisco-only implementation. But, Patrick, that being said, Cisco recently announced that they're going to make EIGRP an open standard. So they're going to be able to write, other vendors are going to be able to write to be able to talk to EIGRP networks. If you believe that that's ever going to happen, let me know, because I'm going to sell Satan a snowblower. There are better routing protocols out there to support than EIGRP. And one of them is OSPF. So open shortest path first routing is essentially the standard routing protocol for pretty much everything now. It's link state. What does that mean? That means that routers in the network keep track of the state of all the links between the routers, and they know when one goes down. What it allows you to do is it allows you to build a topology database for a given set of routers and say, okay, I know the costs to get around the network. And that's great, because if every router in the area agrees on the link configuration and the topology, then they can calculate the best path for any one given router to get to a specific area. And that's great, because that means that the entire database exists on all the routers, and they all know that.
Hey there, Tom. So in OSPF, you know, why areas? When and why would you create additional areas? How does that work?
So it's real funny. OSPF has the concept of an area for 2 reasons. One, areas are kind of, most people use areas as a geographic location. So the finance building is an area, or Poughkeepsie, New York is an area. It's a place where you want the routers to agree on a specific area or specific topology database without needing to allow that topology database to get out. So think about the old days when people were running frame relay and X.25 networks that were slower than dirt, like think dial-up slow. You don't want to try to transmit the routing table for that network down that X25 pipe along with other data. So you allow the routers in a given area to calculate their topology information and standardize on that, and you designate one router, the area border router, to hold the information to know how to connect to the rest of the network. And all is well and good. If you have slow links, yes, make different areas on the other sides of those links. One quirk of OSPF, and you will see this material again everywhere you go. Any area that you create has to attach to area 0 directly. So if you create area 10, and then on the other side of area 10 you create area 20, it's going to fail, because area 20 has to connect to area 0. Why is that? Funny enough, area 0 actually functions as a distance vector routing protocol to prevent routing loops. But for OSPF purposes, you create an area when you have a geographic boundary, or you have an area of instability. So you got a slow link, or you got a satellite link, or something like that. So create an area for the device in there. Because OSPF uses path cost instead of distance, it can do multipathing. So it can find a really good way to get from one side of the network to the other. And it can install backup routes. So in the event that one of them goes down, it can reinstall a new route quickly. Now, one of the things that you may actually see in some very, very old content, and I was actually joking about this with somebody the other day, OSPF is expensive. I always hear that. OSPF is an expensive routing protocol compared to RIP. Because back in the day, the CPUs and routers were like pocket calculators. And so, yeah, OSPF running an area calculation or topology database calculation took a lot more information than RIP throwing its routing table up. And so you saw that a lot. Well, you use OSPF if you've got the extra CPU. You use RIP if you need cheap, dumb, and fast. But that's not the case anymore.
Okay, so a couple follow-up questions on OSPF is becoming a topic here, apparently. You wouldn't create an area for load balance servers then, correct?
Well, so remember that OSPF doesn't carry data. It's just a routing protocol. I would consider putting my data center in its own area. So that's not really that's not a bad thing. The data center is like area 1 or area 3 or something.
Gotcha.
Like that. Yeah.
And that was actually the follow-up question. A data center would be a single area. So it could be. Not necessarily it is, but it could be. Gotcha.
And then again, think about a company the size of Cisco that has an office in San Jose, has an office in Raleigh, North Carolina, and Austin and Minneapolis. I would even go so far as to consider, Minneapolis an area for certain purposes. Now, you don't want your areas to get too big, but that can happen. Analyze what you're trying to do, and use there are volumes. There's probably a van full of OSPF design volumes out there. Enough paper to sink an aircraft carrier.
So it sounds like to me that basically the thing is to understand the protocol, and understand how it operates, understand where it would be best optimized, and that would lead you to be able to design your areas.
Exactly. If you are going to go any further in Cisco land than the CCNA, you will understand the gory details of how OSPF works, and I really mean the gory details. You will actually see routes being installed into the routing table and topology database crunching going on in real time with some of the debugs. For this level of exam, not critical, but yes, there are implications to OSPF design that you need to be aware of, especially when you start throwing in things like frame relay and DMVPN. And if you actually are watching Twitter right now, there's a bunch of guys talking about DMVPN, which is a nightmare scenario for running OSPF because of the way that OSPF behaves over links like that. A couple real quick topics that I want to cover, and if we have questions, we can ask them. But since we're running a little short on time,
yeah, there is one. There was one other follow-up. Lots of OSPF questions. Would you use area 0 for equipment, like within your data center?
You could. Now, let me state this. There is nothing stopping you from making everything in OSPF run in Area 0. I actually saw a site that did that one time. Everything ran in Area 0. But you're not really helping yourself there. The whole purpose of areas is to split off the networking configuration and the routing table calculations into smaller, more compact, quicker subunits. So you could run everything in Area 0. I prefer not to. I prefer the only thing running in Area 0 to be backbone routers.
Okay, so yet again it boils down to understanding the protocol and the use for Area 0 and things of that sort.
And the overriding concern here is just because you can do something doesn't mean you should do it. And yes, you can run everything in Area 0, but
that is always the case. Just because you can doesn't mean you should.
Exactly. So one thing I want to talk about here, on a switch, remember if we think back to last week, a switch is a layer 2 device. And now with the advent of faster processors and things like that, we can actually do routing on a switch. This is where the term layer 3 switch comes from, which is a little bit of a misnomer, but we've been using it long enough. We'll go with it. In order to create a routing interface for a VLAN on a switch, you have to create something called a switched virtual interface, or an SVI. This allows your VLAN to route from between other VLANs. This is actually accomplished in Cisco land. If you've ever been on the CLI of a switch and you type in interface, it shows you a list of all the ports that the switch has connected to it. So interface fast Ethernet 1, fast Ethernet 2, or if you're on an NXOS switch, interface Ethernet 1, or interface Ethernet 3/1, which is module 3 interface 1. But if you want to create a layer 3 interface for a VLAN, you actually have to enter the interface VLAN command, interface VLAN 1, interface VLAN 100. And that allows you to create a routed interface for that VLAN, a switched virtual interface, or an SVI. As we talked about tonight, though, remember that the interface VLAN command is not enabled by default on NXOS. So when you go to type in interface VLAN 1 and you get an error message and go, why won't you work? Remember, you have to go turn that feature on. SVIs are critical if you're going to start routing between VLANs. And if your switch is doing any kind of routing, you're going to need those. But we can also do routing on a port. Every port on a switch, on a layer 3 capable switch, is capable of having an IP address assigned to it and just being a router port instead of a switch interface. I do this a lot when I have to configure switches and DMZs and things like that. The key to remember for a routed port is that you have to type in the no switch port command to take it out of switch port mode and make it a routed interface. Then you have to put an IP address on it. As soon as you do that, you're good to go. If you want to make it into a switch port interface again, you take the IP address off, you type in the command switch port, which drops it back into layer 2 mode.
Okay, so there was a question. Do you have to have a physical interface in the up state for the SVI route interface to be pingable?
Yes, there has to be at least one interface that's up and up. For Cisco newbies, the up terminology, there's the state of the interface and the line protocol, and usually they match. They're either up, or down. I've seen them go up, down on occasion, but very rarely, and that's usually like a weird kind of thing. That's like a trivia question. If the interface is up, that means that there is a port that is receiving traffic on that interface that has something plugged into it, and that brings the interface up. Now, the trick is to configure the interface on a VLAN that's attached to a trunk port. Because the trunk port's passing traffic, all VLANs on that trunk port will be considered up. Now, I've done that before, and the trick there is VLAN 1. Remember, we talked about how VLAN 1 can never be deleted off of the switch. You can be restricted off of a trunk port. You can disallow VLAN 1. And so, but if you need to have VLAN 1 up because it's the management interface, which I don't recommend, by the way, tag VLAN 1 on a trunk port and nowhere else on the switch, and it'll go up. And then you can ping it.
Gotcha, thanks.
So with routed ports, do remember that you have to take the thing out of switch port mode to configure an IP address on it, because switch ports don't get IP addresses. In fact, the command just doesn't show up, but as soon as you type in no switch port, now it behaves like a router port, and you can put an IP address on it, and you can do all the other router things with it. Like I said, typically only seen in DMZs and other places like that, but companies like Facebook run layer 3 to the top of rack switch. You may run into that. So that's it. That's a CCNA DC, at least what I could compile on it in a nutshell. Final tips. Take your time. Read the questions completely. Cisco's really good about not throwing trick questions in there where they which of the following blah, 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 except, or which of the following are not something. They actually hate those questions because they confuse the people. But make sure you read every word. People don't put extra words in questions for a reason. Every word matters for something. But like I said, take your time, but understand that there's a sense of urgency. They want you to get through all the questions. Don't get bogged down on something. If you think you're going to get bogged down on a question, take your best shot. You can't go back on an exam question. Once you click next, you're locked into that. But go with your gut. And do remember that these exams may include simulations where you have to fire up an environment. It's not a real switch. It's a testing engine. But you may have to configure something. You may have to find information on it. Know that those things are going to eat your time up too. So just get used to that idea that you need to be moving along. You need to be answering questions. If you go out and you get practice exams, Cisco Press has some great practice exam simulators in the back of there. Those are questions that are similar to what you're going to see on the exam, but they're not what you're going to see on the exam. So feel comfortable with the basics of the content. Don't just memorize practice questions. So if you do that, you'll fail. You'll run out of time because you'll get confused or frustrated, and you're going to walk out of there and you're going to go, man, I should have passed that. I didn't. I don't know why.
Absolutely, and like you said, budget the time. I remember when I took these several years ago. Make sure you're going through and you're budgeting your time, especially on the simlets and things of that sort. And I mean that'll eat up your time very quickly.
One thing I can tell you, it's not cheating. It's not even frowned upon. A lot of people some people have test anxiety. And I've met several of them. I actually met one in my CCI lab. One of my attempts, the guy got so frustrated he walked out after 2 hours, blew the whole exam because he just didn't take tests well. One of the things you can do to alleviate that for your mind going blank, when you walk into any Pearson testing center, they're going to give you a little piece of paper. It's actually a marker board with a dry erase marker. When you walk into that exam testing center, when you sit down in front of the computer, before you type anything, write down everything you can think of about the CCNA exam on that little whiteboard paper. Everything that you can think of. Subnet tricks. How many hosts are in a /26? How many, this are in that? Or, what's the command that you use to enable interface VLANs on a Nexus switch? Just make yourself a little cheat sheet or brain dump. You're literally dumping your brain onto the piece of paper. Brain dumps actually have a very negative connotation when it comes to certifications. But in this specific instance, I'm talking about getting everything you can out of your head. So you can clear it and go, take a deep breath, I'm ready to do this. And then when you start the exam and you get to that question, what's the command to enable SVIs on a Nexus switch, you can go, oh, hey, I wrote that down. You don't have to freak out about it. The less freaking out you do in the test center, the better off you're going to do.
Absolutely.
Any other questions?
So with that being said, it looks like I'm not seeing any more questions out there. They're pretty clear. So I guess with that being said, hold on here. Okay, that was basically, somebody's basically just saying, thank you for these sessions. They're awesome. They've been very helpful and filled in a lot of gaps for them. So you're doing a great job there, Tom.
It's my opportunity to give back to the community. I mean, the community helped me so much through all of my certifications and things like that. And honestly, I forget sometimes that there are people who don't know anything about networking. And I want to help people that want to learn about networking. That's what vBrownbag is all about. It's about helping people learn things.
Absolutely. Absolutely. And that's why we're all here, right? But definitely. Thank you very much for your time, Tom, and we appreciate you popping on here and sharing your knowledge. And thank you for all of you that hopped on today. And Anthony, thanks for hopping on and co-hosting with me.
Yeah. Thanks for letting me do this.
Absolutely. With that being said, everyone, have a great evening. I'm